This video and the next ones will introduce Benjamin Goddard's master's degree research paper, which he completed in 2023 at the University of Northern Iowa in Cedar Falls, under the supervision of Professor Joshua Gordon and Professor Elizabeth Swansinger. Acoustic analysis allows researchers to treat the acquisition of second language phonology as a series of quantifiable data points. This study applies that quantitative approach to the production of 6 specific French vowel contrasts. The research focuses on a specific demographic, native speakers of American English who are learning French as a foreign language in an academic setting. The difficulty in this field lies in formalizing accent. Because pronunciation is typically judged by the ear of a listener, the results are often tied to individual perception and inherent bias. This research intentionally moves beyond human perception. By measuring physical speech patterns, it isolates the mechanics of the voice from the subjective experience of the listener. This methodology yields a data-driven record of a learner's phonetic development, providing an objective baseline for academic inquiry. The study tests these mechanics by isolating one of the most challenging areas for English speakers, French vowel production. Categorization challenges often arise from the acoustic resemblance between French and English. If a foreign vowel sounds similar to a native one, the learner may struggle to perceive the distinction. This is a result of phonetic mapping, where adult learners instinctively categorize foreign sounds based on the existing phonetic inventory of their native language. Because specific sounds like the high front rounded U are entirely absent from English, they represent distinct, quantifiable hurdles in the learning process. The data for this test was gathered from a carefully tiered cohort of participants. A baseline for comparison was established using a control group of 3 native French speakers from France. The experimental group consisted of 21 L1 speakers of American English. These participants shared a similar educational background, recruited from a public university in the American Midwest. The learners were divided by proficiency. The beginner group included 7 students in their first or second semester. The intermediate group consisted of 7 students who had completed lower-level prerequisites. The final 7 participants formed the advanced group, enrolled in upper-level courses. To control for environmental exposure, the study selected participants who had never lived in a French-speaking country. Their experience with the target language was limited to the context of formal, classroom-based instruction. This strict demographic profile isolates the classroom learner, removing naturalistic immersion as a factor in their phonological development. The methodology focused on capturing speech in a way that could be translated into mathematical values. Every participant completed a recorded 60-sentence reading task. The target vowels were embedded in a consonant-vowel-consonant, or CVC, context within these phrases. By using full sentences rather than isolated words, the study forced learners to produce vowels within the rhythmic constraints of communicative speech. The researchers used acoustic normalization to equalize the audio. This process accounts for physiological differences, such as varying vocal tract sizes and natural pitch among the participants. The resulting data was processed using Praat, a specialized software for speech analysis. Praat was used to extract F1 and F2, the first and second formants, from the audio samples. These formants represent the specific frequency peaks that characterize the unique acoustic quality of any vowel. The researchers calculated Euclidean distance to map learner vowel productions against the native speaker baseline. Linear mixed effect models were applied to determine statistically significant differences. This process removes listener bias, revealing objective truths regarding pronunciation. The data reveals the specific boundaries of L2 vowel production for these learners. While the intermediate and advanced groups were able to produce some vowel contrasts, they were unable to produce all of them. Phonological success is determined by the complex interplay of these biological and environmental factors. The learner's age of onset, the influence of their native language, and their total language experience. The results suggest that while classroom progression drives significant improvement, bridging the acoustic gap may require communicative experience found outside formal academic settings. In the next video, we move into the introduction of the study.